Lesson 8 is talking about exploring the symmetry in quadratics. So we'll be able to find the axis of symmetry and other features of parabola. And your homework will be a worksheet that I post on Google Classroom. So there are some notes to take on and some math to look at. So below are just some real world examples of like arches. And, we know that a parabola is a quadratic. It looks like a U or an upside down U, depending on the type of quadratic. So we know they have a curve. You remember some of this from 8th grade. There's an axis of symmetry. The values in the table are symmetrical. So when we usually see like our table, and then I tell you guys to look for a pattern in the y values only. So maybe you'll see like 1, 3, 5, and then it starts over again. So this is like what we're looking for. This means it's a quadratic. It's making that U shape. And today we're going to be able to realize, we've talked about finding max and min. And you have those notes on how to find max and min. So just looking at this graph, I filled in the values for you. So looking at each point here, so we have -1, 8, 0, 3 from the left, 1, 0, and then 2, -1, and then we see that the values are repeating over here in the y's. And you would say our turning point would be 2, -1, which we call the vertex, which we've used before. Is it a maximum or minimum? It should say minimum. It says maximum, so just get rid of that. I don't know why. Whereas the axis of symmetry, the axis of symmetry is at x equals 2. So when we do axis of symmetry, so the axis of sim is always x equals the number, okay? It's the x value of the turning point or the vertex, okay? So when we have axis symmetry, that x value that goes here is the x value of the vertex. It's the midpoint, okay? It's the midpoint between the two values that hit that x-axis. Okay, is the leading coefficient of the equation of this function positive or negative? It's positive. Do you know why it's positive? It's shaped up. So if you have a quadratic that looks like this, okay, the values are increasing. That means that the leading coefficient or the a value, right, of our quadratic is positive, bigger than 0. If it looks like this, then the leading coefficient is going to be negative. Okay? So whichever way it's opening. If it's opening up, it's positive. If it's opening down, it looks like an N, it's negative. List some points of symmetry. So obviously the ones that are across from each other are the symmetrical ones. So these two are symmetrical. These two are symmetrical. And those two are symmetrical. This is your axis of symmetry. And this is your vertex. The vertex is on the axis of symmetry. It's the midpoint between these two solutions, which we are calling roots, which we'll learn, I think, next lesson. Talk about next lesson. Okay, so here's another example. This is negative because, again, it's going down. This is a maximum because it's the highest point right here. Average rate of change, that's slope. All right, we've talked about that before. Change in y over change in x between the interval that they're telling you. How can we figure out the equation of the axis of symmetry by looking at points that have the same y value? Use the x values of the points that don't have matching y values. So basically, you're looking at the table and saying, all right, where are they not matching? It's the one in the middle. Sometimes they won't give you a middle value, so you have to find it by using the midpoint formula, which I'll show you. What happens to the y values of quadratic equations as x values get very large or very small? The rate of change increases. So if it's shooting up, constantly or shooting down, the rate of change is getting steeper or increasing at a faster pace.